Okay, guys, we're going to start with some factoring on this Unit 6 test that we'll be factoring on the test. So with cubics, we have a formula that we can follow. If you can figure out A and B, really the two forms are basically the same, except for the signs are different. So they both, you can see that they both look a lot alike. No, not a lot alike. They are exactly alike. What's different is the signs. So the way I remember is the phrase soap, same as what you start with, opposite, and then always positive. Same, opposite, always positive. So if we can figure out what to the third gives us each term, then we can figure out what A and B are. So if we start with number 4, A will be x, because x to the third is x to the third, and then what to the third would give us 1,000 would be 10. And so what we do is we write our equation, we put our signs, same, opposite, always positive. So it should be AB, A squared, AB, and then B squared. And so you can never factor cubics any further. So there should, if you can, then something went wrong. So for instance, um, number, say number 10. Number 10 um, isn't a perfect cube right now, but it does have a GCF of 2. So you always want to check your standard factoring rules of GCF and anything else. So they have a 2 in common, so I divided out of each term. Then what to the third gave us x cubed is x. What to the third gave us 27. And so it's like taking the cube root. So my 2 just hangs along till the end. Same, opposite, always positive. Should be A, B, A squared, A times B, and then B squared. So for instance, on number 13, you're thinking that, well, they look like perfect cubes, but before you start doing your formula, they're both divisible by 8. So they both have a GCF. And then from there, we can use our formula, A, B. Sorry, you can't see any of that. Sorry. So then we use our formula, A, same, opposite, always positive. So it's A, B, A squared, A times B, and then B squared. So let's do one more. So number 14 is a perfect cube too. So there is no GCF. So A equals something, what to the third gives us 216, that would be 6. And what to the third gives us A to the third, A. So it's same, opposite, always positive. A, B, A squared, A times B, and then B squared is A squared. So it's just a matter of plugging in the formula. So on the next section, I'm going to do one of each type, one in factored and one in non-factored. I'll leave you with that one to do. Remember, I will be sending out the answers through Remind 101. So let's look at 17. So 17, what we notice is that there is x squared. That means that 0 would have a multiplicity of 2 because it happens twice. And then this one is negative 2 when you solve that. And the way we solve that is we set it equal to 0 and solve. So technically there's 3 zeros. We only see 2, but that one occurs twice. So there's 3 zeros. So that would mean it's either positive odd or negative odd. And so then if we look at our leading coefficient, which is 1, it means it's positive odd. For y-intercept, it's 0. So when your root is 0, your y-intercept is also 0. So I'm going to plot my roots. And then I know that positive odd starts high. Starts high, it doesn't start high. Starts low and ends high. It's like our linear function, it's like our cubic function. PO starts low, ends high. So I'm going to start low. And in order to end high, at the one that's at 0, I'm going to have to bounce off of it and just touch it there, because since it happened twice over here, that's why you only touch there. That's, again, because it happened twice, you only touch at that 0. And then that would be our graph. Alright, so on the back, we're going to do, I'm going to leave number 19 for you to do. But let's do number 18. So x to the third is already good. I'm going to factor this one, x minus 9. I don't know if that'll work. And x plus 2 does work. I don't know why I had to think so hard about that one. And then this x to the third will just tag along. So we see two roots. Two of them are going to be 9 and negative 2. And then this one would be 0, and this would have a multiplicity of 3. That means it happens 3 times. So if that happens 3 times, these two happen once. That's a total of 5 roots. Well, if it's 5, it's going to be either PO or NO, because it's odd. 5 is odd. So looking by the number in front of the x to the third, it is positive odd. So that means that it should start low and end, start low and high. So PE, remember, starts high, ends high. NO starts low, ends low. Whoa, that's not right. NO is the opposite of the PO, which is starts high, ends low, and NE is both low and low. Okay, so this one is PO. So what I need to do is go and mark off my negative 2, my 0. My y-intercept is also 0 because one of my roots is 0. If you don't know your y-intercept, you plug in 0 for x to find your y-intercept. Okay. And so with a PO, I need to start low and high. And so at 0, I'm going to do I'm going to change direction through 0. So when I come back down, I need to change direction. See? At 0, so I kind of have like a little wiggle in the graph, okay? That'll be what we have. So again, it happens 3 times, which is an odd multiplicity, which is why we do a little change in direction there. That's just because it's odd multiplicity. So we're going to come down and do some describing together. So I'm going to do number 21 and 22. So the 1/2 would make it vertically compress by half. It's going to go right 4 and up 2. Remember, if it's inside, it's a horizontal change, and if it's outside, it's a vertical change. So if we look at this one is a reflect over the x. The 3 inside is going to change it horizontally, but it's lying to you. So it's actually a horizontal compress by 1/3, and then the -8 makes it go down 8. Alright, so let's do number 24. So number 24 has a vertical stretch of 2, and it's up 1. So the stretch up 1. So here's our parent. These are the 3 points on our parent. Okay, this is graphing my parent. You don't have to graph your parent. It's just good practice. So what I want to do is I want to stretch it vertically. So what happens is you could do it by hand. -1, -1, 0, 0, 1, 1. You can multiply the y values by 2 because it's a vertical stretch, and you would get these new points. Or if you actually stretched them vertically away from 0, 0, that would work too. So once you multiplied by once you multiplied by 2, which was stretching it, the y values by 2, then you would add 1 to them because we're moving up 1. So you would add 1 to the y values. Okay, so once we do that, when I added 1 of the y values, I still have 1 right here. I now have a 0, 1 point and a 1, 3 point. Okay, so it gets, my graph is not completely perfect, but it gets a lot more stretched out. It gets a little smoother in its curve. So remember, you want to handle the A first, the stretch or the shrink, before you do any shifting. You should be able to complete the rest of them on your own. Remember, it's 6.1 and 6.2. The answers will be sent out through Remind 101 also. Best of luck!